Thank you everyone for coming out tonight. And just a quick introduction about me, and I'll talk a little bit about Couchbase as well. Myself, my name is Kevin Johnson, and I'm with Couchbase. I've been in Singapore for about 10 plus years, and I've been with Couchbase for about over 6 months now, almost 6 months. And I've been working in Singapore long enough that I've been able to see a lot of what goes on with companies in terms of how they develop their applications, how they choose their software, their infrastructure, and much of what they do with their business. And because of that, I'm able to come in and speak with people and kind of relate what I've seen and the decisions that get made when they start going through this. So what I'm going to do to start with is I'm not going to presume that everyone here knows about databases. So the first couple of slides, if you know databases and you're familiar with them, then these first couple of slides may bore you. But again, I just want to make sure that everyone that I'm speaking to here is in some understanding of how data management works. Okay, so with that, what we're going to do is talk about how relational databases and NoSQL databases differ. And it's important to understand this because many people may not have necessarily have heard what is a NoSQL database versus a relational database. And to start with, why do we have databases? It's just a fundamental question. If you're designing an application, if you're putting something together, why do you have a database? It's because you need something to store the data, right? You need something to be able to put data into, maybe process it in some way, organize it in some way, and then ultimately get that data back out maybe a different way. And this has been a common need basically ever since computers started. And this is over 50 years ago. And what has happened is databases have become the core of how it is that we process our data. And what gets built on top of that, of course, is your application. So all of you who are developers, you know this. When you go to develop an application, you say, I've got part A application and part B, I need a data store. So how exactly do relational databases work and why is it they function the way they do? Is they were built on a rigid structure of basically tables that have rows and columns. Now, I've given this talk before and there's a little story behind it. So I have a colleague that works in Thailand, and the way she explained this to me is she said, explain this to people as if they have no idea what a database is. And she made an important point, which has stuck with me, and that is that if I get up here and tell you, oh yeah, you got rows and columns, and then you've got your schema, and you connect all that together, and you start building it, some people just glaze over and they're not necessarily paying attention. Those of you who are developers, again, you understand these concepts. And I don't want to presume that you do. So then the way to think of this is, let's say that you have a closet and you have shelves. And let's say you like t-shirts or you like shoes, whichever it is. And you think to yourself, I need to organize these. Now, who knows? Maybe you're the person, you just throw them in a pile and you go up and do the smell test and, okay, that's good for today. Or maybe you're the person that says, all right, I want to be able to go in and say, today's going to be red, today's going to be blue. I want it to match with my shoes or my pants, whatever it may be. So thinking of that term, you have your shelves that you're going to start to organize things based on, for example, color, size. Is it short sleeve, long sleeve? Is it a high top shoe? Is it a low top shoe? Is it sandals? Whatever that you choose to organize that, that's how you would start to structure that, is based on rows and columns. And then you can add, of course, additional tables to that. You might say, I want a table for just my dress shoes and a table for my tennis shoes or my sneakers. Now, the difference between that and a noSQL database is that with the old schema, you're bound by those shelves and those, basically that table format. You can't really go outside of that. You can't just say, for example, that I want to be able to just put all my clothes or my shoes in one place and be able to easily find them and say, you know what, I want to mix up my red shirts and my blue shirts, but I still want to have a way of organizing them that I can easily find them. Plus, I want to be able to scale this out, meaning that let's say that I have multiple closets or multiple houses, whatever it may be. I need to be able to take that same method and duplicate it. Maybe I'm becoming a professional organizer for your spouse or your children, whatever it may be. But either way, it's something that you need to be able to scale. And rather than just piling everything into one closet, you say, I may need to take this and bring it somewhere else. Well, that in essence is what a noSQL database is. It's being able to take data and then have what are called worker nodes that facilitate organizing that data and spreading it across what's known as a cluster. The cluster can be multiple options for data stores. And this makes it much easier for you to manage multiple instances of this rather than being bound to that single instance. Okay? So those of you, again, you understand this. It should be fairly easy for you to adopt these concepts. Those of you who are new to it, think of it in terms of a relational database, single instance. With noSQL, it's going to be in cluster. And I'll give you another sort of metaphor for this in just a minute. All right. Now, the origins for this, of course, is because relational databases are older than noSQL. noSQL is a newer structure for data management. And because of that, it is more flexible and more in terms of what's called a modern database. Relational databases, in case you didn't know, they've been around since the 1970s. And it was developed by a famous person. His name is Donald Chamberlain, and he came up with the first SQL query language, which is used to manage a database. Okay. Now, let's bring that back now to the actual structure that I was mentioning. When you have a relational database, you're bound to a particular type of structure here, which means you have a server, database, schema, table, and row. When you move that over to noSQL, and in this example, I'm going to be using Couchbase, you put that into a cluster, which I've already explained. Now you're going to move it into a bucket, which is what your database is called. Then you have a scope, which is going to be that schema, which is going to be the multiple, in essence, closets that you have. Then you're going to have your collection, which is like your table or your spreadsheet. And then finally, you're going to have your row, which is an individual document. Okay. Now, how does this look? So those of you, again, who are familiar with this, you may be able to easily pick up on this, but those of you who are just introducing it, this may look like something you've seen, for example, say in Microsoft Excel. It looks like an Excel spreadsheet, right? Well, that's basically what a table is. And when you start connecting things in a relational database, you're connecting them by, for example, a common piece of data. It may be an ID, could be a name or some key, whatever it may be. It allows you to then connect data together within a relational database. And with noSQL and the JSON format, which is what is used with a noSQL database, it is more like a document. And you saw this earlier in John's presentation. So he had a different document here, but he was basically using key and value, but it's the same sort of structure that you see. And this tends to be a more flexible approach to managing data, as you'll find. It's much easier for someone to come in here and simply add in another row to this. They can just come in and hit enter, add something else in, and that's a part of that. It doesn't impact over here where if you start adding in additional columns or additional rows, that impacts the overall schema and how that data gets accessed. Now, how do each of these databases scale? And this is probably one of the biggest things that you're going to find when it comes to relational versus noSQL. Going back to that cluster example that I was referring to. With a relational database, you really only have one option, and that is you start piling resources on top of a relational database. And what tends to happen is people try to get more performance by throwing more money and resources at relational databases. It's a common problem because we think back to where it came from. These relational databases, they're very old. They haven't been able to adopt or change based on the architecture that's needed. Ultimately, what happens with a relational database is you kind of hit a certain level and you really can't go any further. And that's, you've thrown as much in terms of resources as you can get at it, and you're not going to get any more performance out of it. With clustering, what happens is now you're not bound to that type of format. So going back to what you saw, for example, is you can now cluster things. You add more instances. So let's think of it in terms of an apartment building. If I have an apartment building, sure, I can upgrade that apartment. I can add a couple more floors, but if I just have too many people for that and I need more performance or more in essence, ability to store things, I just add another building. And if that's not enough, I add more buildings. And I can continue to do this, and there's no impact to my overall ability to manage that data, because that's the joy of clustering. So I'll give an example, quick show of hands. How many people here know what Kubernetes is, or at least have heard the term? Okay. And you all know that because that's basically the infrastructure design of the future. That's where everything is going. It started off with Docker containers, and then Kubernetes came out, and now everything that you ever hear talk about is like, oh yeah, we're doing clusters, we're doing microservices. And databases have had to respond to that as well. Now, you may ask yourself, moving on from that, you may ask yourself, well, if noSQL is such a great database, why don't more people use it? Why is it we don't see that more often? For example, in John's presentation, he was talking about MySQL. And why is it that more people aren't doing noSQL? And it's because legacy data. Many companies, they started with MySQL, they might have started with MS SQL, they might have started with Oracle, whatever it may be. It's hard to move away from that. It's difficult to just simply say, okay, we're going to take all this data and just put it somewhere else. As you know, it's difficult to do that. And what people come to us, and specifically companies, they're in a scenario where they're trying to move on from that data or facilitate in some way that building that keeps going up. They can't continue to just keep adding resources to it. So in many circumstances, like I said, developers will go out and they use what they know. So again, quick show of hands. How many people know SQL? Yeah, so how does that determine what database you wind up using? So you say, I'm going to build an application. Okay, let me get my database going. So I'm going to use MySQL. I'm going to use MariaDB. I'm going to use MS SQL. You just made that decision because most people don't know anything else. Now, let's talk about why it is JSON and SQL++ change that conversation, and why it is that people now don't have to make that decision of going with MariaDB or MySQL or Oracle. And we're going to start off with just some very fundamentals of this and going through why it is JSON is a more flexible format, and why it is that SQL++ enables you to make that switch, use a noSQL database, and not be impacted by some of those challenges that you see. Okay? So, diving right into this, let's go back to a table that we saw. And here we have that similar structure. It's a rigid table. We have the data that's set here. And now a company that says, well, I want to be able to take this data and use it in a noSQL database, what am I going to have to do? Well, first of all, the benefit is that you can simply take this data and combine it into a new document. Now, when we work with companies, this is one of the first conversations we're having with them. And when developers see this, this tends to be the more favorite format. It's exactly what John was talking about with his APIs. When people start ingesting data into a noSQL database, this makes things much easier to do that. It makes it much easier to just simply start putting data into this, and then you want to be able to get it out. But that's where the other half of that conversation is, which is the SQL++. Because most people, once they throw it into a JSON format, they know, okay, well, that's going to make things complicated because now I can't just use SQL. I have to use something else to get that data. But that's not true when you're using SQL++. So let's go through a couple of things. Don't worry. Those of you who aren't real familiar with this, and you're not familiar with noSQL and JSON, we're going to take it back a step here. But I just want to go through this so you can see exactly how this is different with a relational database versus noSQL, and this is JSON format. So here what we have is we have, again, our sample table. And these are multiple tables that we have here. And what we're able to do using a JSON format is take different parts of data and pull that into one, in essence, table. And of course, we call that a collection. We can do this with arrays. We can have nested array objects. And by doing so, it changes the overall format of how we're able to structure this data. And it makes it more efficient, and it makes it easier to manage and change as needed. We're no longer bound by that rigid table format that you saw previously. So now, how does SQL come into that? Well, this is what it will look like. So the key advantage here is if you know SQL, then you know SQL++, because they work and look the same. And this is a new concept. So I'm going to pause here for a minute, because what I found is when we speak to individuals about this, they're surprised at this. They didn't realize this existed. They were not aware of this. And I actually just had a conversation with an individual. They approached me before this presentation even started. And he told me the reason he'd come to this presentation because he wanted to see this. He's currently working on a project, and he was interested in understanding how this was going to be able to work, because he had never heard that SQL even could work with a noSQL database, because he needs to be able to use a more modern database. And that's always an interesting conversation when I have it, because again, this is something that has been available. Now, Couchbase is a company, speaking for Couchbase, we know we're not that popular. We know we're not out there as much. So many people, they may not necessarily know that this is available. Many people, they do a search for noSQL and they find something else, and that goes down a different path for them. But here with Couchbase, again, you're able to take exactly what you know, and that's why I wanted to see that show of hands, and you can immediately apply it to a noSQL database. All the same queries are going to work, and we're going to dive into this a little bit more here, but let's take it back a step, because those of you who may not understand this, I want to break down exactly what's involved here. There's no trickery in this. When you get into an SQL statement, and John was showing some in his presentation as well, there are just some basic concepts that go into this. You're doing a select, which means you're going to take parts of something. I'm selecting a something from something, and then I start to extend that and say, for example, going back to the closet, I want to select red shirts from size medium, where they have a design on the front or a design on the back, or I'm selecting my blue shoes that are, for example, leather, or they're sandals. And each one of these criteria is allowing you to then start to filter down into what you're looking for. And what you see here, for example, is we're just looking at some data here, and we're going to get more into what this data deals with. And you can play with this as well if you're interested. Here, we're just looking at airport name, city, and country. And we're just saying from a travel sample, and then from a country where France. So we're just saying we are looking for airport name, city from the country of France. It's the exact same. There's no trickery in terms of SQL and SQL++. It works exactly the same. Now, what else is involved in this? It's the exact same way in terms of the data management capabilities, which means that not only are you able to go in and select data and start organizing that data, is you can start to go in and manipulate that data as well. So that means that you have the ability, of course, to do your inserts. You can create or add additional documents. You can delete documents. You're able to go in and update documents or replace them. You can upsert documents as well. You're also able to go in and do merges. And this is a big one. Having this capability as a part of this means that you're able to now start pulling documents together where previously you may not have been able to do that. And there's additional functionality. We're going to dive into it here in some other slides. And I just need to be cognizant of my time, so I think I'm going to have to speed up a little bit. But one of the other key aspects of this is you can also do ANSI joins with SQL++. Again, you're not losing that key functionality as a part of this. And this is probably one of the core capabilities that we get asked about, is because how many of you have had to write an SQL query, and getting the joins to work in an efficient manner was your biggest roadblock? Show of hands. It's okay, don't be shy. We all had to do it. Okay. So you all know what it's like. You're sitting there trying to do a join, you run the query, and you're going, where is it? Where's that data? What's taking so long? Well, you have the same capability here, but the difference is I'm going to show you how SQL++ changes that problem. No longer do you have to sit there and go, why isn't this working? Why is this taking so long? You're going to be able to break down the query much better with using tools that are built into how SQL++ works. So let's take a look at some additional features here. With the ANSI join, you can also do complex joins. You can use in clauses, and much the same functionality that you see with joins. Everybody remembers those tables and when we were learning SQL, inner, outer, left, right. All those are built in as a part of SQL++ as well. Okay. Arrays are also a possibility when it comes to SQL++, and this you saw a little bit earlier when I was highlighting how you can take parts of data and be able to list that in your JSON document using arrays. And this is a key capability because, again, you're able to build other documents from data that you already have in JSON format. And this is a key capability. So from a Couchbase perspective, this is a key capability for many of our customers. Again, it's about being able to take the legacy data and building new documents, new data stores, and managing that data in new ways that previously you were not able to do. Subqueries are another part of this. So I remember this from my days and having to work with SQL. It's probably one of the toughest parts of when you start writing queries is you have a main query, and then you need to be able to write a subquery that's going to pull in and possibly even calculate data from another source as a part of that main query. Now, you may remember that sometimes people tell you from an application development standpoint, or even running reports or data management, you don't want to get into this because doing so really piles on a lot of usage when it comes to processing and so forth with your queries. So typically they tell you to stay away from this, but sometimes you really have no other choice because, again, going back to that rigid model, if you have no other way of getting the data, someone comes to you and says, I need this. Sometimes a subquery is the only way, but you're still going to be able to do that using JSON format, noSQL. Now, I'm going to skip through this a little bit because we are getting down to the last couple of minutes here, and there's some key things that I want to go through, but some things I'm going to talk about here, extend a little bit more, is functions. So this is a key capability as a part of one, SQL++ and also Couchbase, because many customers and users, they need to be able to build their own functions as a part of SQL++. And this is a unique functionality for this, because being able to go in and trigger certain events as a part of this is probably something. How many of you have needed to do this? How many of you have had to use functions as a part of your queries? Okay, a couple of hands there. Okay, so you don't lose that functionality here. And on top of this, you can extend it with SQL++. So many of these features that you have seen now can actually be applied, as I'm going to show you here, to trigger specific actions. Now, again, this is something that's specific to Couchbase. So what we're actually seeing here is we have a JavaScript function in Couchbase. And what this will then allow you to do is then create references to it that you can then use within your SQL statements themselves. So a lot of times when we show this to people, this is a great functionality for them to be able to, one, have programming that is looking for specific things outside of the SQL++ language, and then bring that capability directly into their queries, their reports, their data management, etc. Now, search functionalities within this, of course, we also have full text search as a part of SQL++. So this is, again, another key capability. Those of you who may not be familiar with this, the way I like to sort of simplify this is the Google search. You start getting into just wanting to search for words and not necessarily look for specific criteria, then you're able to do so by using text search. We can also do prepared statements on this and named parameters. So I'm going to skip through some of this stuff. And let's see. Okay, there we go. And then finally, we can do transactions. So the key part of this is we have scenarios where customers or users, they want to be able to execute something within their data management. And they are worried that, however, making a change to that data may be irreversible. So if you've ever done this, if you ever worked with database management and you're in a scenario where you're thinking, I'm going to have to compile or bring all these documents together, but I'm worried that if it doesn't go right, am I going to be able to reverse that? And that's exactly where these transactions come into play. So you begin a transaction, you can set a transaction, which then has a save point, and that allows you to then roll that back if a special condition is not made or not met. And then finally, you can commit that transaction and say, okay, proceed forward with that update, proceed forward with that merge, whatever it may be. Function, again, all of these functionalities come into that. Now, let's understand, taking all that capability, how you're now able to apply that to the noSQL side of this. What does this mean for you overall? Well, going back up to, you say the 10,000 view is having all this power as a part of a noSQL database means that you now have all those things that previously you used with a relational database, but now in a cluster format. So that means you have a cluster that you can use an SQL-like language and then be able to scale that out. But what we're going to do here is show you how you're going to scale that and keep the performance maintained as a part of that. So remember what I said earlier about being able to look at your query and understand what the problem is. Another part of what I was mentioning was indexing. So you may have heard me reference this. Well, what exactly is an index? An index is the way I relate this is it is a section of sub-documents. It's a group of sub-documents. And we all know this. Whenever you do a select star or select name from something, what happens? That runs through the whole table. And even if you try to narrow that down in some way, you're still having to scan the entire table for whatever that query is. Well, indexing changes that. With indexing, what you're able to now do is select a group of sub-documents and say, only look for documents that meet this criteria. So then going back to that closet sample, you say, I'm looking for red shirts that were made by Gap. And you're qualifying that. And by doing so, whenever you run that search in the future, those two criteria must be met, and that does not change. So it's a more efficient and a better performing query. Now, you can also distribute the query execution. So again, going back to that cluster architecture, no longer are you in a scenario where you have to push queries through a message queue and basically wait for your turn. Instead, you can distribute those queries to different searches on different services. And this allows for a far more efficient method of that. And this applies to different areas. So you can even do it, for example, with analytics, full text search, all of that. These are different parts of a noSQL database. Why? Because going back to that reference of a cluster, you're now able to take everything and put it into different parts of a cluster so that it functions separately and it does not bog down the entire database performance. So finally, this is one of the built-in tools, and I'm talking about Couchbase here. So what we're able to do is analyze your query, going back to that reference that I made with the join part of it. You can now write a query using the language that you know, SQL, in SQL++. You run it through Couchbase, and what it will do is tell you, is this an efficient query? Now, you may say, oh, that's great, Kevin, but I know my query isn't efficient. So what does that really help me with? Well, we take it a step further. So we're going to take it to the level of being able to tell you what the problem is with that query, as I'm going to show you here. Now, again, because this isn't a cluster architecture, there's also different options for this. If you're just developing your app, sure, you can put everything in one node, run everything that way, everything's fine. When you start pushing it into production, then you say, okay, now I know that I need to have my data on a certain number of nodes. I need to have my indexing, again, that grouping, the query on different nodes. And as your app starts to perhaps develop more usage, more users are coming in, whatever the scenario may be, you can say, you know what, I need to add more nodes, or I need to scale up certain nodes to be able to perform better. If you were in a relational database, think again back to that tower that we saw. You don't have that option. And this is the difference by combining these two things, SQL++ and a noSQL cluster database. So going in the familiar tooling, again, this is more on the Couchbase side of this. So what we're going to do is I'm going to show you how you can analyze queries in Couchbase. And this is more on the Couchbase side when we go through all of this. We're going to show you how you can import data, and I'm going to give you a QR code. So you may not be able to sign up for this immediately, but I'm going to give you two options that you can go through here. One is you can just jump into Capella, and I'm going to show you where you can find this data. If you want to play around with SQL++, I'm also going to show you how we have a developer's playground. And by the way, there's no catch here. This isn't some sales pitch. We're actually just trying to get out to the developer community, because what we found is that people have asked us to do this. They've said, we didn't know you all did this stuff. We didn't know Couchbase was in Singapore. Can you come and please talk to people? So that's actually why we're here with John, is we know that people are having interest in this. So we're trying to reach out to the community. And on that note, what we're interested in is hearing from you, because if you would like to see us demonstrate something or demo something and come and showcase something, this is what we're interested in doing, because we do want to get out into the community and show you all that what is possible, not only just with SQL++, but using that as a part of Couchbase, for example. Okay, so if you're interested, you can jump into a free 30-day Capella trial. If you just want to play around with this and see this for yourself, what you can do is we have 3 data sets that are included with the cloud trial. So the stuff that I'm getting ready to show you, you can go in and test this yourself. There are also a number of tutorials. I'm going to have links that are going to be in the presentation. So if you want to go and play around with this, you're welcome to do so. But this is just highlighting where you can import that data. And what you'll do is it's very simple to set up. You just go straight in, hit import. It'll say, okay, I'm going to import this data set. It'll set up basically the bucket, the collection, and everything else for you. You don't have to do anything else. And after that, you can go in and immediately start querying data. There's a number of these tutorials that are available, and it'll run you through just how you have to set everything up. So going back to that SQL reference and being able to understand how your query is performing, I told you that we would be able to go through and analyze that and tell you, is this a query that performs well using SQL++? And what can you do about it if it's not? So in this scenario, what we see here is it's running an execution time of about 2.1 milliseconds. And that's kind of slow. But what you can do is you can test this and say, all right, well, can I improve this? And the answer is yes, because we have what's known as an advise button. So going back to what I was saying is that, it's great that we can tell you what the problem is, but if we can't fix the problem, then what does that really help? But Couchbase is able to do that, because what we'll do is we'll run that query, and then we'll actually be able to point to the parts of the JSON document and say, if you look right here, if you build an index, meaning if you group some of this data together, your query will work better. And then by doing that, what you're able to do is go in, build that particular index, and then go back to your history, because you don't lose any queries. Everything's going to be kept in Couchbase as a part of this. I can remember this. I don't know if you all remember the days of working with MySQL Workbench. Sometimes you delete a query and then you want to go back and use it, and you realize, oh, yeah, it's gone. So I didn't save that tab. So what we do is we automatically save all your queries for you in the history. You just pull that back up, run it again, and you're ready to go. So now what you can do is you can actually go through and do what's called an explain. The explain will go and tell you, based on the query that you're running, exactly what parts of your database you are accessing. And if there is a new index here, for example, it will highlight that. And it will say, hey, you use this index to run through and scan this data, which improved the overall performance of the execution. Okay. Now, with everything, there are best practices. So just like SQL, there are things that you should do and you should try to remember. So again, it goes back to what I was saying at the beginning. The same thing applies to us. You don't want to throw in a bunch of joins into your queries. You don't want to pile on a bunch of indexes. That's probably one of the first things I can tell you from my experience being 6 months with Couchbase, is that I see customers, they get a little bit too happy with indexes. So they try to index every single thing, but then they try to use those indexes to speed up their queries. But unfortunately, they're just making things slower. So use indexes efficiently, use joins efficiently. Create indexes, of course, that include all the fields for a specified query, and offset limits. So if the results are too large, then you want to limit that with your queries. I remember that from the SQL days. So if you have a scenario where, for example, you're just pulling in too much data, you need to be able to go in and limit that. And of course, where you use your select clause, so only use the relevant fields for that. And of course, you can also use with Couchbase key value stores. So instead of using select, you use the key values as a part of the JSON document format to pull in your data. You're not now having to use that select statement, and that can also make your queries more efficient. So I'm a little bit over time, apologies for that, but if you're interested, there are some additional documents and tutorials that are available. So just to let you know a little bit about what this is, if you're interested in these slides, this barcode or this QR code will give you the slides from this presentation. And as I mentioned, there is a live developer playground. So let me mention a little bit about what that is. This is a totally open, free to use developer playground to go in. It has tutorials built into that, which means you can go straight into it and it will run you through step-by-step building queries, polling data, and how that works. So if you're just interested in introduction to noSQL and SQL++, feel free to jump into that. If you have any questions about this, you want to contact me after this, feel free to do so. And I'm happy to answer those questions. Otherwise, thank you all for coming. I hope you enjoyed the pizza. Have a good night. Yep.
Okay, so thanks very much, Kevin. Does anyone have any questions for Kevin?
Different from the other databases like Mongo or
Okay, excellent question. I don't know if everybody can hear me. Okay, excellent question. So that's probably the number one question that we get here. How are we different from, sorry, I'm not sure what that is. How are we different from MongoDB? Well, for starters, MongoDB is a master-slave architecture. Couchbase is not. So Couchbase is a cluster architecture, and we are active in nodes, which means that as data is being passed directly into the cluster, it is being distributed on all of the nodes. There is no scenario, for example, where data is on one node or it's not on another node because the master node has not transmitted it. Second of all is the SQL++. That's probably one of the key differentiators for how you use Mongo versus Couchbase. Third is performance. We have had so many scenarios where people compare us in terms of scaling versus MongoDB. And I'm not going to try to hide this. Again, I'm the technical guy. So full transparency, Mongo as a small database, single node database, yes, performs very well. It's hard to beat that. But when you start scaling up MongoDB, what we find is that many people come to us and say, we've had Mongo, we started off our app with it, but it's not working. Because when we start to scale it up, it's not performing as well as what we expected. And when it comes to in-memory cache, that's another thing that MongoDB doesn't have. So Couchbase has one caching immediately. All data goes straight into cache, memory cache, and then it is distributed to our storage. So that means that anything that is not found in memory already will just simply be pulled from the cluster and fed to the application. So in terms of performance-wise, we're already faster in that sense, especially when you start to scale us, because all of our data is held in memory. I hope that answers your question, unless you want to. Do what? Cassandra? Oh, yeah, we also do, I guess we perform better than Cassandra. I mean, Cassandra is obviously a similar architecture, but in terms of performance-wise, now you're making me get into the sales pitch. I'm trying to, I'm sorry, John. So on that side, what tends to happen is Cassandra, again, is a more focused solution for something. Couchbase is a more all-encompassing enterprise solution. So that means that people will start off with Cassandra, but what they find out later is that, oh, I have to get this because Cassandra doesn't have it, or, oh, I have to go and get that because Cassandra doesn't have it. It's the same with like MongoDB. They have to use Redis, and all of a sudden you're piecemealing solutions together. Couchbase, you don't have to do that. So Couchbase, it has all of those things. It has the cache, it has analytics, it has query, it has data. Everything that you would need for that is all included. And you'll actually see that if you go to that free trial, for example, with Capella, you'll see all of that included. Any other questions?
My question is towards the RDBMS versus the noSQL approaches, because years back, usually people tend to think of document databases when they think of cloud applications, like for financial application-based tools, they go for RDBMS. But in the current scenario these days, can we already say that all the use cases of RDBMS you can replace with NoSQL approach, or are there still cases where for these cases you need to use RDBMS NoSQL and replace it at this time?
Okay, that is an excellent question. So Just in case nobody heard that, the question was, is there a scenario where you would still use a relational database versus a NoSQL database? And the answer is, of course, yes. Irrelevant of Couchbase, there's always going to be scenarios where we might go and talk to a customer and they say, I have all this data in a relational database. Should I move it to a NoSQL? And we might just say, no, you shouldn't. You can keep that data in a NoSQL database and just pull data from the relational database when you need it. But if this is legacy data and you're concerned that if something happens, you're going to lose that, I mean, absolutely, we would tell you to keep it. There's also certain applications that you simply cannot get rid of the relational database. Either the code is so old or the version of that code is so old, and those companies can't move past that, or they're not going to move past it. So in those scenarios, yes, I would say you may have to stay with a relational database, but what you would then do is put a NoSQL database like Couchbase on top of that to then pull data, as I'm saying, from that and provide a source of that data to your other modern applications.
Actually, it's kind of an extension to that question. Actually. So, Couchbase stores the data in form of article or document that go into form. So, does that lead to use cases that can be utilized using Couchbase?
That's an excellent question. So let me define that question a little bit more. What he's asking is, because we are a document store database, are there scenarios where we would be limited in terms of what we would be able to do as a NoSQL database? Of course. So for example, we may have someone come to us and say, and that's actually to the conversation I had earlier, they were asking about graph. Does Couchbase do a graph database? The answer is no. We're not a graph database. We are a document store database. And actually, that's my fault. In my presentation, I didn't mention that in the beginning there, is that specifically tonight, we would be talking about a document store database, which is what Couchbase is, but there are different types of NoSQL databases. So I hope that answers your question, but yes, in Couchbase, someone comes to us and says, I need a graph database. The answer is no, that's not what we do. Any other? Okay.
We have a document size limitation in MongoDB. So similarly, we have a new limitation here. And one more question. This SQL++ is works on, I mean, does it work on only Couchbase or any other MySQL database as well? Who owns it?
Oh, okay. So the question was, is SQL++ exclusive to Couchbase? I would say yes, it's exclusive to Couchbase. I don't know of anybody else that uses SQL++. Do what? Okay, yes. So if you're hearing that for the first time, yes, I don't think you can really go anywhere else for that. So part of why we're talking about this is because, one, I don't want to come in here and try to talk to a community and make it seem like I'm selling Couchbase, okay? So please don't interpret it that way. We're here to talk about the functionality because many developers, when they learn about this, they want to know more about it. They start immediately asking those questions, much like what I was showing in the slides. Can you do inserts? Can you do updates? Can you do merges? Can you do multiple joins and subqueries? So this is meant to be an informative session to talk about what SQL++ can do, but yes, it is exclusive to Couchbase. You may have heard of it in other ways. If you've ever heard of N1QL, that was another name for it. But we're trying to just keep it to one name, and that's why I didn't mention those other names as a part of this, is because when I start doing that, people go, wait a minute, so what's the difference between N1QL and SQL++? It's SQL++. Just think of it that way. All right.
There was another half to the question.
Oh, sorry.
Yeah, the document size.
Oh, document size. Is there a limit to the document size? Wow. I'll put it this way. Most documents are going to be between, say, actually, no. And sorry, requalifying your question. No, there's no limit to the document size, but I think I know where you're going with that. And let me explain why. I had a customer that asked, I have video files. Can I upload that to Couchbase? And the answer is yes, but you would probably need to break that up into different parts, upload that to Couchbase, and then access them and put them back together from there. And that's just simply because if you're piling on these ginormous documents into Couchbase and you're expecting some miracle performance out of, say, a 2 GB file, yeah, that's probably not going to happen. You're going to have to split that up. But we can handle binary files as part of that. So it's not just JSON, you can also put in binary files. Does that answer your question? If not, I tell you what, we can talk about it after the presentation, so. All right, another question? Okay.
Yeah, I,
Yeah, it's very interesting. So that's why I'm again asking another. It's a distributed database, right? So you have
Yes.
a cluster, multiple nodes.
That's
So
correct.
how do you handle fault tolerance?
Okay.
Do we replicate data? If so, how the transaction and what do you call it, data messaging?
Okay. Okay, I want to make sure I get all the parts of this answered. So let's start with part one is how do we handle fault tolerance? So because it is a cluster, let me actually go back to a slide here because this will probably make it more relevant to what I'm explaining. And let's see, we'll go to this one. So of course, our cluster will look something similar to this. There may only be one worker node in this, but let's say that we lose this node as part of that. What would happen in that scenario? Now, because Couchbase is active, what that means is that the data is on all of the nodes. And you're not losing any data if you lose a node, because all of it is on all the nodes. And the part that I haven't mentioned is one, this is sort of cut in half. If I were to show this to you in an architecture, is you'll have active and then replica. So half of it is the active data that's being passed or being used, and the other half is a replica of other nodes. So if you lose a node, immediately what will happen is one, there's no impact to performance. You're not going to see a scenario where suddenly the app is not working because again, all the data is on all the nodes. So then what would happen is the node will start to rebalance. It will one tell you that, hey, you've lost a node, you need to rebalance. You can then proceed to do that. A new node is brought up. And it's basically a part of all the functionality that we have built in. It will basically start saying, okay, this needs to go here, this needs to go here, and it will distribute all the data to the rest of the nodes. So that answers part one of the question. What was the other part?
Talk about transaction.
Okay, so
let's say we commit transaction, right? After complaints is not possible, right? NoSQL.
what's not possible?
The atomicity, consistency, integrity, the typical RDBMS acid properties.
No, it is. It's absolutely possible.
But with distributed system and the gap theorem, so we can only have two, isn't it? Consistency and
So
how do you get
So I get asked this, whether or not we are able to satisfy the CAP theorem in all three aspects. I know that it's hard to believe, but depending on the scenario, the answer is yes, we can satisfy that. I know that sounds like an impossible claim, but I think if I had time to sit down and explain it to you, you would see that we can meet all three of those scenarios for that. And that typically is surprising to most people, and I find a lot of pushback on that. But I say again, give me the scenario where you feel we're not going to meet that.
Just a follow-up with that. So when I insert a document, and let's say I have 50 nodes, and the insert is only completed after it has inserted to all 50 nodes?
No. So, okay. So first of all, in that scenario, if you have performed an insert, it is immediately being transmitted to all the nodes. It's not a scenario where you're waiting on nodes for that to be transmitted to. It's immediate. And it would pass through to the entire cluster instantaneously. I get asked this question because people are thinking in terms of a master-slave architecture, in that if I bring in a transaction of an insert, it's going to be here, but it's not going to be here right away, right? So maybe similar to what you're asking is, people might say, if I write data to this node and then I read it from this node, are you telling me that I'm not going to be able to get that data? Is it going to be different because I've already passed the data here, but it's not there? And the simple answer to that is because this is not a master-slave architecture. It means if you do a write, it's on all of them instantaneously. It's active. Does that answer your question?
Yeah, it's interesting because if you have like a lot of nodes and it's just instant, it's
Yes.
very fast.
That's correct.
But there's no lag as such.
No, there can't be lag. There cannot be lag on it.
How can we ensure that? Because lag is not something database control, like it can be due to some network congestion or something like that.
Okay, now you're throwing in another factor. So if there is a scenario where you have network lag, of course, that may play into multiple clusters that are spanned over a network. Of course, there may be lag. But the way the database as a cluster itself works, there would be no lag because the data would be distributed immediately. It would go straight from RAM to the entire cluster. I know what you're leading to. You're saying, if I have this node closer to where the data came in, but further down my network here, is there going to be some latency? Of course, there might be a little latency as a part of that. And thankfully, I have someone here who can probably give more of the details of that. My manager here, Jeannie, who has far more technical aspects of that, can probably explain it because he's had some customer experience with this to explain why there might be lag and how that may impact it.
Yeah, I guess the key thing is, depends on your access pattern, right? If you're assuming you're talking about KV, key value operations, right? So basically, when you decide to write a block of data, so whether it could be a document, it could be anything, Couchbase will, in your SDK, will predetermine where this data will go. Okay, so for example, it goes to node number 1. You're always going to go node number 1 to get your data and read your data if it's a KV operation. Now, query is different. Query, we need to go to the query node. We're going to pass that. We need to understand, then we need to go and get that. That's a different story. We'll talk about it later. Now, when you talk about that KV operation, so you write that into the node. Okay. First thing Couchbase will do is asking, okay, do you have any special requirement? If no, I give you a handshake straight away after you hit the memory. Okay. If you hit the memory, right, you get a handshake straight away. You can go and tell your user. Okay, this is the quickest response. Then Couchbase will do 2 things. Couchbase will replicate the data into a different node so that we have a copy, and then we'll persist the data in the disk. That's what Couchbase will do. Now you can choose later on, because this behavior is called asynchronous, right? For those who knows about, means I give you a handshake first and then save it later, asynchronous. You can do sync if you want. You need to pass that parameters to Couchbase and say, you know what, don't give me a handshake until you got options. Until you replicate the data, then give me a handshake, right? Then you have some assurance. Or even deeper, you replicate the data, then you persist to local, then give me a handshake, right? The most secure one will be you replicate the data and you persist in majority of the nodes, because this is a 3-node cluster. What about 10 nodes, 15 nodes, 100 nodes? You replicate to majority, and then you persist in majority, then give me a handshake. Now the choice is yours. As a developer, as an architect, what do you want to do? Right? If you want fast and you don't care if I lost the data, for example, session management, right? Your shopping cart, if I lose my shopping cart, yeah, big deal, but you're not losing any money. But you're doing a transaction, that's a very different story altogether. Okay? Couchbase gives you that flexibility. Now, remember what Kevin says at the beginning of you constantly have debates. Should I use legacy RDBMS or should I actually have something that out there can help me to facilitate a lot more reads? Because 2-node Couchbase cluster can take up to 3 million operations per second. Okay, this is a performance. I just talked to a gentleman right there. He's a chief digital officer from Dyson. He told me that I love Redis. Right? What happens if something is as fast as Redis and sys database at the back? Is that, yep, I want to try that as well. Okay. So you constantly have a debate with your architect, with your developer, with your business user. Do I actually solve my payroll problem, which is a transaction problem? Or do I have something that can manage all of my operations? How many have you got an online shopping experience? What's your shopping to buy ratio in terms of how many times you interact with the app but you're not buying anything? The shop to buy ratio is extremely high, more than 1,000 to 1. That means if you're using traditional database, you always need to commit all of those. Guess how much data you're going to store? How expensive that will be. Talk about Oracle. Who use Oracle? Your company use Oracle? Thank God. MySQL, SQL Server, MariaDB, all right? Kevin mentioned all about vertical scaling, right? People don't want to use noSQL because they don't have SQL. They don't have capability to handle transactions. Yeah? What happens if I tell you? Unfortunately, we have to have a label, which is called noSQL. I think this is a multi-model, next generation data platform, ladies and gentlemen. Right? I don't think we can simply label that as noSQL. I don't think it's fair. You're looking at so much capability, and Kevin only shows you half of it. Right? The other half probably wait until the next meetup. Right? We have full text search, replication, right? Mobile sync. Imagine that the same database, you can put it on an edge device that will work offline when there's no internet connection, act as a local storage and compute at your Raspberry Pi. How's that sound? And then if the internet resumes, the data will sync automatically without any programming. It's all by configuration. Those are the key capability to make a modern application for your customer. All right. So next time you're having a debate, ask them, why do I have to choose between SQL or noSQL? Why can't I get the best out of the both worlds? What do you want to trade? Time or money? All right, the call is yours.
Thank you, Jeannie. Any other questions for tonight? Okay.
Actually, yeah, sorry, Kevin, there is there were a couple of questions in the online
in chat?
from the online
Okay.
audience. So one of them, I think you actually addressed this. It was about writing to a cluster and then reading again. There were lots of good questions about that. All right, I think you sort of addressed that. The other question is how does Couchbase behave if a node reaches the limit, let's say a connection limit or a CPU limit?
Okay, just for the audience, make sure everybody heard that. The question was, if a node is hitting a particular limit, how would Couchbase respond to that? So one, we have obviously alerts that would tell you that your cluster is reaching capacity. And two, we have the ability to, in certain scenarios and certain configurations, you will need to scale a cluster up yourself. But in certain scenarios, you can have it to add resources to that. But I don't want to dive into all the specifics to that, but it basically gets into your bucket configuration, et cetera. So yes, there is some auto scaling capability, but overall, if you need to scale that cluster, you will need to go in and add additional resources, but we will tell you that there is a resource problem with your nodes. We will tell you if there is a particular node that is failing, if it's having a problem, if it's not responding, whatever it is, we will be able to tell you that. I hope that answers that question.
Okay, all right. Well, thanks very much, Kevin. Lots of great questions. Thank you for
Yes,
the
thank
audience too. Do you have the slide with the QR code? If you want to see the slides,
Yes.
Then and you haven't already registered either on Zoom or with the QR code here, then make sure that you do that so that that's the one on the left, isn't it?
Yes.
Yep. And of course, feel free to follow up with Kevin or Ginny or any of his colleagues.